Of course, it is difficult to remember all the reduction formulas which I wrote in the previous board. Instead of that, we can find the reduction formulas by using the sum and difference formulas, or by using the steps below. Here we have 5 steps for finding the reduction formulas. The first step is to find the primary directed angle for the given angle and determine its quadrant. Find the primary directed angle and also determine the quadrant of the primary directed angle, that the primary directed angle locates where. The second step, determine the sign of the function in the corresponding quadrant. We can use a stick abbreviation. A for all, S for sine and its cofunction, T for tangent and its cofunction, and C for cosine and its cofunction. The third step is express the angle, the primary directed angle, or the expression as sum or difference with a suitable quadrantal angle. It means you should write the primary directed angle as a sum of 2 angles, of which the first angle is a quadrantal angle, or you can write the angle as a difference of 2 angles, that one of them is the quadrantal angle. The fourth step has 3 other steps. The first step is use the sign from step 2. The second step is if the quadrantal angle is an odd multiple of pi over 2 or an odd multiple of 90, replace initial function with its cofunction. We know the functions and its cofunction. Sine is the cofunction of cosine, tangent is the cofunctions of cotangent, and also secant and cosecants are cofunctions of each other. If the quadrantal angle is an even multiple of pi over 2 or 90, keep the original function. You should not change the function into cofunction. And also eliminate the quadrantal angle, and in the fifth step, find the trigonometric value for the remaining angle. Here we should solve an example for better understanding. In example, we have reduced each trigonometric value. The first one is sine 585 degree, cotangent 300 degree, cosine of pi over 2 plus alpha, and tangent of 2 pi minus alpha. How can we reduce these angles into a single angle? We are going to start from the first one. We have sine 585. In first step, we should find the primary directed angle of the given angle. The given angle is 585. The primary directed angle is 225. Also, we should identify the quadrant of the angle. The quadrant of 225 is the third quadrant, because it is greater than 180 and smaller than 270. Also, in the second step, we should find the sign of the function in the given quadrant. A sign is negative in the third quadrant because of the stick abbreviation. And in the third step, write the primary directed angle as a sum or as a difference of 2 angles. We can write sine 225 as sine 180 plus 45. We wrote this angle as the sum of 2 angles. The first one is a quadrantal angle because the terminal side of the angle locates or coincides with the negative axis, with the negative side of x-axis. And the second angle is a non-quadrantal angle. In the fourth quadrant, use the sign from step 2. Sign is negative in the third quadrant. In the second step, 180 or the quadrantal angle is an odd multiple of pi over 2, or it is an even multiple. 180 is an even multiple of 90 degree. So we should take the original function, which is sine. In the third step, take away the quadrantal angle. We can write sine 225 as sine 180 plus 45. So we should remove the quadrantal angle, which is 180, and in the fifth step, find the value for the remaining angle. Here we should find the value for 45 degree. And we know the value of 45 degree, or the sine of 45 degree, which is square root 2 over 2. So finally we have found the answer for sine of 585, which is minus square root 2 over 2. And we have used these steps. Also, I'm going to solve some other examples for better understanding.